want to thank everybody for joining us today on this webinar. My name is Luis Tienda. I'm the product manager here for UV Products, and I've been with Fulham for right around 11 years. Let's go ahead and get started. So some of the things we'll be covering today is what ultraviolet light is, the differences in the Ballast technologies, rough comparison of UV lamps and UV LEDs. We'll review Fulham's Ballast offerings, standard products, programmable products, new products, and we will also be going over the new UV demo kit that we've created. So electromagnetic spectrum is a range of wavelengths and frequencies over which electromagnetic radiation extends. So things such as radio waves, microwaves, visible light, X-rays, and gamma rays and such. Visible light spectrum is the wavelength that is typically seen by the human eye. It has a shorter wavelength, right around 700 nanometers to 400 nanometers. Ultraviolet light is electromagnetic radiation with wavelengths ranging anywhere from 10 nanometers to 400 nanometers. One of the most common places you're going to find UV is in sunlight. So I just want to start off by saying that any and all exposure to UV can be dangerous and harmful. So whether it's short-term, long-term exposure, UV radiation will cause skin and eye damage. So you always want to take proper precautions when working around it. The UV spectrum, typically we know these as UVA, UVB, UVC. With UVA, their wavelengths are typically around 315 nanometers to 400 nanometers. This is very common in sunlight. Rays from UVA are ones that tend to penetrate deeper into the skin compared to the others. UVB, on the other hand, that range is from 280 nanometers to 350 nanometers, and those rays usually account for about 5% from the sun. UVC itself is the one that produces the most energy out of the three, so it is best used for germicidal application. The rays themselves typically get absorbed by the Earth's atmosphere, so they typically don't reach Earth's surface. UVC is the one that is the most dangerous out of the three, so you always want to be able to take the greatest of safety and always use proper protection when working around that. So here we're just breaking down, the common uses of the technologies, the differences in the Ballast and their technologies. So, there's what's known as preheat, rapid start, program start, instant start. They'll have different wiring methods from one to the next. Typically, instant start Ballast will be wired in a parallel configuration. The instant start Ballast do not provide any sort of preheat to the filament, as when you compare to a preheat, program rapid start application where you must wire according to being able to provide preheat to the filament. Typically, 2-pin lamps and there's also 4-pin lamps. They can be used with, an instant start, as opposed to with the 4-pin. It is best, of course, to use a sort of preheat filament in order to extend the life of the lamp itself. Out of the three, program start will be the best overall in performance and for the life of your lamp when using a 4-pin type lamp. Here on this slide, we're giving a breakdown of comparison with a cold cathode type lamp and a hot cathode type lamp. With cold cathode, it's typically paired with an instant start ballast. They usually tend to output slightly less UV radiation when compared to a hot cathode lamp. They require no preheat, so you do get an instant on and there is no additional requirement for additional energy when preheating the filament. With the hot cathode lamp, which will be a 4-pin lamp compared to the 2-pin cold cathode, these will allow for higher power densities, which will result in higher UV intensity. Although the slight delay in starting the lamp due to the preheating, which will happen either during ignition or before ignition, they tend to be best overall use case. They also can be used with either instant start or preheat start type ballast, which of course, as I mentioned, the best performance you're going to get will be with using a preheat type ballast. So further breaking down the technologies and really give you, advantages and disadvantages, we're showing you what comes with, when using instant start, rapid start, or program start. So as an example, we'll use, all three of these technologies paired with a 4-pin type lamp. So in terms of cost, the most effective one will be instant start. And then the downsides that come with that will be, your reduction in lamp life with the more and more cycles that happen with the lamp. So overall, with the instant start, you will achieve, less starts compared to a preheat design. So there is, as I mentioned, no preheat. So you'll tend to see more and more blackening of your filaments over time as you use the lamp. With instant start, it is not recommended for cold applications. Looking at a rapid start type of ballast, it falls more in the medium cost range. However, the benefits will be that you get an increased lamp life over using an instant start because of the preheat. However, the preheats tend to only be provided for a short period of time and generally are not as good as using a preheat start ballast. I'm sorry, a program start ballast. As I mentioned, it is improved life of the lamp over an instant start, but it's still not recommended for colder type applications. Now, the best performance and the best solution I feel will be a program start ballast. However, it is at a higher cost. However, you do tend to get a lot higher life expectancy from your lamp, achieving upwards of 20,000 starts or even higher. It does have the better preheat design as it provides during and after ignition of the lamp. And again, where applications call for frequent on and offs throughout the day, I highly recommend using a program start ballast. And for colder applications, program start will be the best option compared to an instant start or a rapid start. So here we're just listing, the various types of applications. In the next slide, we'll kind of just give a scenario breakdown of when one might be used over the other for an instant start or for a preheat start type ballast. And again, we're picturing here some various applications that correspond to, its wavelengths. And again, those types of applications that I mentioned in 2 slides before this, in a scenario where your ballast is continuously being cycled on and off throughout the day, you're going to want to use a preheat start ballast. Otherwise, you'll be going through lamps like crazy. In an application where the lamp is on for several days, several hours, and there's minimal cycling of the lamp, an instant start ballast would also be a good solution. But again, anywhere where the lamp is cycled on and off continuously, you want to go with the preheat start type ballast. So here's where we'll break down, UV lamps over UV LEDs and really see what the impact on an application is going to be. With UV LEDs, the improvements that they have over the lamp is the fact they have no filament. They have the ability, once the technology advances, to achieve longer life. However, technology itself hasn't advanced yet to reach where a UV lamp is today. The other positives from using an LED would be, it has no toxic gases. There is no mercury. There's no risk of glass being broken in an application where that might pose a problem. LED is a point source output, therefore, allows you to, design to a specific area or coverage. And in the future, you have the ability to kind of match that of a lamp in a shorter, smaller profile. And of course, LEDs don't require any sort of preheat, and is essentially, they're instantly on, and cycling on and off do not affect, the long-term life of the LED as it does for a lamp. Now, with UV lamps, the positives you get are the fact that they're not limited in the UV spectrum that they can achieve compared to an LED. UV lamp technology has been around forever, much, much longer than UV LEDs. UV lamps can achieve, much higher energy outputs compared to today's, LED technology. They are a 360-degree output, which can be beneficial in some applications, such as an air handler, water treatment facility, in a place where, you gain from the fact that, the UV radiation is in all directions where air or water might be passing through. And at the same time, it allows for just a larger spread of coverage. UV lamps, in those applications, the technology itself is the most efficient today. And one of the bigger things that people tend to care about is how much is it going to cost you? Today, UV lamps, it's still the lower cost solution. LEDs are still just generally more expensive and still not to the level of performance of that of a UV lamp. So here's just another chart comparison of UV LEDs and UV lamps. So in the next few slides, we're going to go over Fulham's product offerings. But before I jump into that, I kind of just want to give a breakdown of what one would need to ask, or what we would ask when trying to pair a proper ballast with a lamp. So such things as how many lamps are you using in your application? What type of lamps are you using? Are you using high output, standard output, very high output amalgam lamps, as high as 2200 milliamps? The wattage of your lamp, are you using a 2-pin or a 4-pin type lamp? What sort of application is it? Are you constantly turning it on and off? You're cycling it out throughout the day? Is there any specific safety certifications or EMI requirements that you need for your installation or your application? What sort of installation voltage? Do you require 120 volts universal input? This will help us really narrow down a ballast solution for you. And of course, if you do have the lamp spec sheets, that's always for us to pair the right ballast with the right lamp is the best thing to have. So here, breaking down some of our non-programmable ballasts. We do have offerings for standard output lamps, 425, high output lamps of 800 milliamps, even higher current lamps up to 2.1 amps. Their BIOS wattages will range anywhere from 45 watts all the way up to 320 watts. We've done some custom designs that even go up to 700, 800 watts for very high current 8 amps, 7 amp lamps. Some of the models shown here, however, do have the ability to customize their output current within a certain range and have the ability to be factory set. So if you are using an 800 milliamp ballast, right, and you have a 600 milliamp lamp, you're going to be overdriving it. If you really do require 600 milliamps or be close enough to that lamp current, some of these designs have the capability of ordering them to that specific current. Some of the ballasts come with an indicator for the lamp, knowing when it's on or off, and that's 5-volt DC signal output. And then there's some ballasts that come with an additional 5-volt signal output to indicate when there's power to the ballasts. The ballasts are also capable of operating 1 or 2 lamps. Now I'll be covering one of our new programmable ballasts. This is our SHS-15P UNVH model. This is a new programmable ballast that features a lot of, features. Um, this is, it differs in the sense of having the ability to be programmable. This particular model has a current range of 800 to 1200 milliamps. It has all the major certifications for North America and other international markets. It is a universal input ballast, so you can operate anywhere from 120 to 277 volts AC. It has a max load rating of 310 watts for applications where you're powering a lamp from 800 milliamps to 1050 milliamps. And it is rated for 260 watts max when loaded with lamps operating from 1060 milliamps to 1200 milliamps. The ballast can operate one or two lamps. It now has the capabilities of operating down to lamp ambience of negative 20 degrees Celsius. The output can achieve a remote distance of 30 feet from the lamp. And it comes standard with both 5-volt DC signal for the lamp and for the ballast. As well, we've designed something brand new, which is a 5-volt signal capable of turning the ballast output on and off without having to remove the output to the ballast. I'm sorry, the input to the ballast. So what it means is when this connection is open, the lamp will be on. When the connection is shorted, the lamp will turn off. And some of the capabilities that have been built into the ballast are the ability to log lamp hours that are fully resettable, ballast powered hours that are non-resettable, ballast output hours that are non-resettable, and real-time temperature of the ballast. You also do have the ability to store lamp information on the ballast. So to make it easier on somebody replacing the lamp, and they need to find, the manufacturer, the model, this is something that can be directly stored onto the ballast. So from the side of a maintenance, department, that might be easier for them to just to, read off the ballast and say what lamps are compatible for this ballast. The ballast is also fully addressable, and this has been designed to work directly with our new SHS DISP UV ballast display, which I'll cover in the next slide. One of the next slides. The ballast can interface. The ballast itself also has capabilities of interfacing with other, customer interfaces and controls that a customer might have. This can all be done through the RJ12 port, so long as the devices have the capabilities of communicating with the I2C command protocol. So this is just a mechanical drawing of the SHS-15P. And this is our second model that we've released of the programmable line. So this is the SHS-4P UNVC. So this model will have all the same feature sets that I mentioned of the SHS-15P, with the differences being that this has a current range of 340 milliamps to 840 milliamps. So you're basically able to cover standard and high output lamps under a single ballast. This is also the first ballast that we've designed for the Japanese market that can operate with an input of 100 volts AC. It already has the proper PSC safety certifications required for sale in Japan. It has a 95 watt max load when operated with an input of 100 volts AC and 110 watt max load for all other voltages of 120 or higher. And here we just is a mechanical drawing for the SHS-4P. And this is a slide that's just being used to show the comparison between one of our standard models and one of our programmable models. So this will just give you kind of like a little bit of a high level view of what the differences you get from using just a standard ballast compared to, one of our new programmables that have all the different feature sets that were described earlier. And here we show our new UV smart ballast display. This is intended to work with our new smart programmable UV ballasts. The display itself has the capability of monitoring real-time data stored and logged directly on the ballast. So you're able to display the lamp's hours, lamp status, whether it's on or off, the ballast hours, its output hours. The display also has the ability to set end-of-life hours on the ballast. This is really used or intended for use for maintenance. So you have the ability to ensure the lamp is serviced within the manufacturer specified timeline. As well, it is intended to be used with the audible alarm that's integrated into the display, which will alert the user once the hour count has been reached. The display itself will also have a 5-volt DC digital output that is used to monitor the lamp status. So it could be tied into an external LED indicator, or it can even be tied directly into a building management system. It also will have a digital input of 5 volts DC, which can be used to remote on and off the ballast from the display. So it's a low voltage signal intended for you to control the output of the ballast from the display itself. The display also has the ability to use the digital input as a standalone hour counter. So what this means is you can take a non-smart ballast that has a 5-volt output for the lamp indicator, feed that into the display, and you're able to now track your lamp hours and set alarms and triggers for that as well. The display also has several methods of powering the display. So you're able to power it with 24 volts DC by way of the barrel jack input. It has the capability of working with 12 volts AC to 24 volts AC for anywhere where you have an HVAC application that's using a low voltage transformer. USB-C connection, so when you hook into your PC, someone's servicing, you have the ability to work with our software and you can pull information directly from the display. And the display can also be powered directly from the ballast when it's plugged into the RJ12 port from the display to the ballast. The display will also come with a normally open, normally closed relay connection that can be tied to lamp hours, can be tied to status of the lamp, and use that to tie into any application where that might be useful. Additionally, there's another RJ12 port for future sensor implementation. And this display has the ability to monitor up to 127 addressable ballasts. And here we just show a mechanical drawing of how the SHS display works. This display here shows all the locations of the connections, as well as it shows kind of like a rough configuration of how multiple ballasts are wired to one display. Typically, they're wired in parallel, as is done with I2C connections. Here we're showing one of our 8-inch UVC LED modules, which we've developed recently. This consists of 9 LEDs. The module is powered off of a constant voltage supply. It does have additional onboard circuitry to reduce variation and won't affect the UV radiation output. It has a nominal power of 4.5 watts with a radiated power of 45 milliwatts. And here we show the mechanical drawing for this 8-inch module. And here is the irradiance measurements that have been done on this 8-inch module. Here we have pictured our new UV demo kit. We specifically designed this to showcase the new technology found in our UV Smart Ballast and our UV display. And now I'll have Stephen Flemings give an overview of how to use this UV demo kit.
Hi, I'm Stephen with Fulham, here to share with you today our new programmable smart ballast line. We have two new smart ballasts we've just released, the SHS-4P and the SHS-15P. The SHS-4P has all the features you expect from our SunHorse ballast line, including LED indicators for both power to the ballast and the lamp, and a new remote switch, which is a feature we just added, all the certifications you need for both domestic and international business, 120 to 277 volt input, and 1 or 2 lamp operation. We've also added some incredible new features like programmability for the ballast from 400 milliamps to 800 milliamps with this SHS-4P, or 800 milliamps to 1.2 amps with the output of the SHS-15P. This one again can handle up to 100 watts of loads in either 1 or 2 amp configurations, and the 15P can control up to 330 watts of load. We also added intelligence straight into the ballast. So this has a smart chip in it that you can access through this RJ12 connection. We've taken the input from our customers over 20 years in the UV space and made it possible for them to do so much more with the ballast, cutting components, reducing costs, and increasing features. Let's get into how you can use this in your product today. I'm going to show you a few of the features, so come along for the ride. Right here I have in front of me this panel which allows you to experience all the different features of this ballast using our new SunHorse display. This display is a commercial grade display that could be used inside of your technology, or you could use your existing display to access the I2C chip in here directly through firmware. We can share that firmware schema with your team and help you develop a connection to the ballast directly. You can go one of 2 routes, and we want to enable you as an OEM to make a successful product either way. So reach out to your regional sales manager to learn more about that, or to get one of these panels and explore this directly as you will with me here in this video. So let's get started. Right here in front of me I have the SHS display. Right now it's connected to an SHS-4P ballast inside of this unit with a lamp. Right now the lamp is off. I'm going to depower this unit and actually disconnect this display because I want to show you a few functions that you can do without having a display or without even plugging into the RJ12 connection. I mentioned earlier this remote switch. This is a dry contact switch that will allow power to remain in the ballast, have charged capacitors in the ballast, but will actually cut output to the lamp via a dry contact. So you just connect to this remote switch port right here, and then you can power the ballast, or you can take power away from the lamp while the ballast remains powered. So I'm just going to turn this on. You can see this display is disconnected here. This display gets power through 24 volts AC/DC, or 12 volts AC, or a USB-C connector, or this RJ12 to the ballast. Right now, the ballast is powered, as you can see from this ballast power signal. Here's the lamp power signal. So the ballast has power, but the lamp doesn't, because
this dry contact has the lamp off right now. If I open the dry contact, it will power the lamp on and the signal here will turn on. Or by closing the dry contact, it will disconnect the lamp and the ballast will remain powered.
So a really cool little feature that allows you to either make a safety interlock or connect to a control board, or perhaps disconnect a large group of ballasts without creating an inrush current problem. A really great feature that we added to give flexibility to OEMs who want to access some level of intelligence without having to use a display or an I2C. So I'm going to just connect really quickly this display again. It's going to go ahead and search. I'm going to remove power first just to give it a good reset. Add power again here. So it's powered up, it's connected to the ballast, it's searching for the node, and it's found the node. See there? The lamp is off. Let's go ahead and turn the lamp on, and that ballast, or that status of the lamp will change. Here we have the lamp time and then the lamp status. And down below here we have the ballast time and the operating time. And then we have the digital input and the digital output setting. I'll explain more about that in a moment. We have the relay setting. It's a normally open, normally closed relay here. There's a digital input here and a digital output here. We'll go into those in a moment. The temperature of the ballast is listed here in 44C. It has a little hour counter for how long you've deferred the end of the life. So you can put the end of the life right here into this display, and then you can snooze it the lamp when it hits its end of life. And then there's a node here. This is just identifying that this SHS4 here connected to the I2C is node number 44. You can have up to 144 nodes connected to this display via I2C, and it can control them all as a group or individually. So it can take full advantage of the I2C protocol. So let's go into the menu and look at a little bit of the functionality here. Number one is the lamp. So let's go in this menu here and look at the lamp settings. You can add the lamp brand and part numbers, so whoever's servicing the lamp can understand what they need to replace it with. That can be added via the USB-C port here using a Smart Set software and a computer. That software is available through your Fulham Regional Sales Manager. You can see setting here, number 3 is the expected life. You can actually change the expected life of the lamp right in the software through the click of a button. So I've changed it from 8,000 hours to 3,000 hours. When it hits that 3,000 hours, it can trigger a few things. It can set an alarm off. I'm going to turn it back now to 8,000 hours. So really very easy, a super feature. Here's a notification that will go off when the lamp hits its end of life. So right now it's set to go off at the end of its lamp life. Let's just take a look here. I can turn that off so that there will be no visible alarm here. The visible alarm can be set through this setting. There's also an audible alarm that this has, it's called the buzzer. We'll see that later in the menu. So I'm going to turn this alarm back on. So now when the lamp reaches its end of life, it will have the alarm on. You see here this option for nodes. That just gives you the ability to decide, okay, do I want the end of all of my lamps to trigger the alarm, or just the one that's directly connected to this display now? So you can change the setting of which nodes trigger that setting. There's lamp service. This is where you can snooze the lamp if it's hit its end of life, now or later. And then there's the parameters of the lamp. This is a fun little menu where you're able to change the lamp on or off directly from the display. A very cool feature. There's also the ability to change the output current. This is kind of where you get into the futuristic type stuff. Being able to reprogram a ballast while it's connected to power, changing it from 800 milliamps down to 400 milliamps. You can see the light dim down there. And now I'll change it back to 800. These ballasts really are the ballast of the future. All this intelligence right in the ballast, directly connected, immediate access to it. It's an incredible, incredible product. So those are the lamp settings. We're going to go down one and look at ballast type. You can actually use this display with a non-smart ballast like the SHS11 or the SHS1 and take some of the lamp indicator signals into the ballast to trigger into the display to trigger certain things. We're going to leave that where it is because we have a smart ballast connected. So like I said earlier, there's a digital output and a digital input. You can change the functions of this. First of all, you can make it so that it reacts to all the ballasts or just any of the ballasts or one of the ballasts triggering that digital output. So right now we're going to look at the function and say, okay, what is this doing? It's giving us a 5-volt output when the lamp is on. If we want it to give us a 5-volt output when the lamp is off, we can actually change this over. So the lamp is on right now. I've changed the setting to give us 5 volts when the lamp is off, and so you can see here this 5-volt signal here has turned off now. I'm going to turn it back to give us 5 volts when the lamp is on. I've saved it and you can see it turn on because the lamp is on. Turn it back to give us 5 volts when the lamp is off. I'll take power off the lamp and it will give us those 5 volts right here at that digital output. So do you want 5 volts when the lamp is on, or do you want 5 volts when the lamp is off? You can change that setting right here. So I've set it back to give me 5 volts when the lamp is on. The digital input port allows you to take in a 5-volt signal to change the lamp status, or to create essentially a type of dry contact situation where you provide 5 volts to a dry contact or 5 volts to a relay, and then when that switches, it will react accordingly. So let's look at that for a minute on this input. So right now it's pulling up, meaning it's looking for 5 volts coming in, and when the 5 volts come in, it's going to turn the lamp on. So I'm going to remove those 5 volts right now, show you the lamp is going to shut off. Okay, so the lamp is off because it's no longer receiving 5 volts. I'm going to turn that back on for a minute. Let's change this around a little bit in terms of how it works. we're going to go ahead and say, okay, instead of looking for 5 volts, I want you to look for a pull down signal. And essentially that makes this a type of a dry contact situation where it's going to pull down 5 volts from it, and when it senses that there's a close contact on that pull down, it will turn the lamp on. So you can change that setting right here. A very cool function, a lot of flexibility to work with your existing controls and setup. I'm just going to change that back. Let the lamp turn back on there. You can change the relay and decide if you want it to be based on lamp status or the end of life hours. So right now it's set to change the relay over whenever the lamp turns on or off. So to turn the lamp off, the relay switches over. Turn the lamp on, the relay switches back. You can actually change that to end of life instead. You can also add a sensor on or off here. You can change the audible buzzer on or off. Pretty powerful feature for an audible buzzer. Gather the node info, that's just reading the software on the Ballast. Get the display info, the software on the display, and then the communication port, you can configure your diagnostics and addressing right here in this menu. So those are all the various features in this Ballast. That's what this demo kit's meant to do. That's it for me today. Reach out to your sales manager today to get more and to learn more and to get one of these in your hands today to play with to add features to your product. Thank you.